All right, so previously we talked about the Arrhenius definition. Let's talk about the Bronsted definition. Now, Bronsted saw this and he saw the issue with something like NH3. So he said to himself, how in the world do we resolve the fact that ammonia is a base? If we react it with an acid, it does neutralize it. Well, Bronsted said it's really the verbiage, it's how we're defining it. So we're going to say that an acid still gives H+, but we're going to change it to say it doesn't dissociate, it is a proton donor. So under the Bronsted definition, an acid is anything that donates an H+ in solution. Now, a base is just the opposite of this, it's antithetical. So if you don't donate a proton, you have to accept a proton. So underneath the Bronsted definition, our base here is going to accept a proton. Specifically, it's going to accept it from what it's in, the aqueous solution. And this is going to give us H+, BH+, and the OH-. Now, what this does is it allows us to produce an OH- in solution without needing an OH- within the base itself. So under the Bronsted definition, a Bronsted base is something that accepts a proton, and if it accepts it from water, this is how we're going to get the OH-. Now, when these two react, we end up getting the H+, the OH- and the H+ coming together to give us water. We end up getting the A- combining with the BH+ complex and the A-. Our water is going to cancel off both sides, and this is how we end up getting a salt in the case of the Bronsted definition. What happens is that our base will accept the proton from our acid. This will give us an anion, a cation, and these are going to come together to form our salt. So the Bronsted definition is broader. We can take any Arrhenius acid and base and rearrange our reaction to make it look like a Bronsted acid or base. So any Arrhenius acid base is also a Bronsted acid or base, but not the other way around. There are definitely things that are Bronsted acids and bases that are not Arrhenius acids and bases. Now, to be honest with you, the definition for the acid looks the same between the Arrhenius and Bronsted definition. So really the distinction here is how the bases behave. The bases are going to behave by accepting a proton, whereas in the Arrhenius definition, the OH- has to come from the base itself. But ultimately, we end at the same conclusion. We still can explain how H+ and OH- concentrations are changed in water based on the acids and bases, and also how we're able to produce a salt. And this is going to give us the ability now to work with weak acids and weak bases much more easily than we could in the Arrhenius framework. That said, we're still seeing this AQ. So to get beyond the AQ, we're going to need to move to the Lewis definition of acids and bases.